In the previous video, we reviewed the goal and function of daylight harvesting, and in this video, we will cover the two different control methods that can be used to implement daylight harvesting. Daylight harvesting can be accomplished by utilizing an open-loop control system or a closed-loop control system. Both will adjust the artificial lighting in a room based on the natural light influence, but the key difference between the two is what light the daylight harvesting sensor is actually measuring. In an open-loop system, the daylighting sensor only measures the amount of natural light entering the room through a window, while a closed-loop system measures the combination of the natural light entering a room and the artificial light being provided by the fixtures. This may seem like a subtle difference, but the installation and commissioning of a system will drastically change depending on which is selected. Let's start by reviewing an open-loop control diagram. As we can see, the sensor is positioned to only measure the amount of natural light entering a room and adjust the dimming output accordingly. This control diagram is a straight line, and this is why it's called an open-loop control. Here is a graphical layout of a small office that utilizes open-loop control for daylight harvesting. We have the daylighting region near the window, and a daylighting sensor that is installed next to and facing the window, so that it only measures the natural light influence and not the artificial lighting. Often additional shielding or masking of the sensor is needed to ensure that artificial light is not being measured. There are several considerations to take into account with an open-loop control system, and the first is something that has been mentioned several times so far, and that is sensor placement. Open-loop daylight harvesting systems are critically dependent on correct sensor placement. If the sensor is installed in a location where it is affected by artificial lighting, the sensor readings will be incorrect, which will likely lead to control issues. Another key consideration to an open-loop system is the calibration of the control. As open-loop systems only measure the amount of natural light influencing the space, the time of day, weather conditions, and the seasons all affect the calibration of the system. This makes the proper calibration difficult and could result in control issues with the daylight harvesting fixtures. Now that we have reviewed open-loop control, let's review closed-loop control. Here is another control diagram, but this time for closed-loop. We can see that the daylight harvesting sensor measures both the natural and artificial light influences. The controller will then dim the artificial lights up or down based on this measurement. There is an added portion of the control diagram, and that is the feedback loop. As the sensor measures the combination of the lighting influences, it can see what the actual light level in the room is doing, and this is why it's called a closed-loop system. Using a closed-loop system in our previous small office example, we can see that the daylight harvesting sensor is placed inside the daylight harvesting region so that it can measure both the natural light influence from the window and the artificial light influence from the fixtures. While sensor placement needs to be taken into consideration with a closed-loop system, such as ensuring the sensor is within the daylight harvesting region or not placing the sensor directly above an uplight, the exact location is not critical. This simplifies the installation and ultimately the calibration and operation of the system. In regards to calibration, this is where a closed-loop system is also beneficial. Since closed-loop systems measure both the natural and artificial light influences, the calibration of the system can be completed any time of the day, regardless of the weather or seasons. Open-loop systems and closed-loop systems can both function properly, but closed-loop systems provide for an easier installation, setup, and calibration, and ultimately better end-user comfort. This is why Touche uses closed-loop daylight harvesting for both the Room Manager and the Smart Pack. Either device can be used to control the daylight harvesting fixtures using the closed-loop control method so that the artificial lights will dim up and down throughout the day in order to maintain a desired lighting level while reducing energy costs. As with everything we do at Touche, we wanted to keep the setup and calibration of daylight harvesting as simple as possible. This is why the daylight harvesting for both the Room Manager and the Smart Pack is configured and calibrated using the free Touche Insight app.